So once again, this is the, as I was saying, this is only 7 strong acid, and so it's a good idea, as it says over here, to commit this short list of strong acids to memory. So because the ionization of strong acid is complete, it's 100%, it occurred 100%. So the concentration of a hydronium ion, H2O plus at equilibrium, is equal to the starting concentration of a strong acid. So take a look at this. So let's say they're asking us, calculate the pH of aqueous solution of those acids. HI is a strong acid. It's on that short list of a strong acid. HNO3 nitric acid is a strong acid. HClO4 is a strong acid. They are all strong acids. And their concentration, take a look at their concentration, 0.035 molar, 1.2 times 10 to the negative 4 molar. And HClO4, all their concentration, their starting concentration are also the concentration of a hydronium ion, H2O plus. It's exactly the same. And so if you want to find the concentration of the hydronium ion, it is equal to the concentration of the strong acid, only strong acid. But if you need to find the pH, so pH is a negative logarithm of a hydronium ion, so you put hydronium ion and you will find the pH of that acid. You only can do that when you have a strong acid, when you know the concentration of hydronium ion. So, and they gave you the pH of a strong acid. HCl is a strong acid. And they said if the pH is equal to 4.95, what is the concentration of HCl? So we know that the concentration of a hydronium ion, it's a 10 to the negative pH. So once you will find that concentration of a hydronium ion, it is equal to the concentration of the acid, because the strong acid and the hydronium ion concentration, they're equal to each other, only for the strong acid, and by the way, for the strong bases. Strong bases also are, the list is also very short. It consists of the hydroxide of the group 1 elements. Group 1 elements, we call them alkaline metals, and the hydroxides of the heaviest alkaline earth metals, group 2A, but only the heavier, the one with the higher molar mass. And the dissociation, when they dissociate, we call it dissociation because strong bases are ionic compounds. When they dissociate completely, 100%. So take a look at the list of the strong acid. It's a group 1 hydroxide, lithium, sodium, potassium, rubidium, cesium hydroxide. Do you see one arrow? They will dissociate to make ions, positive ion, and the negative OH minus ion. And for the group 2 hydroxide, only the heavy one, calcium, strontium, and barium, not magnesium here. And when they dissociate, they form completely dissociation, one arrow here, and they form OH minus. And if we wanted to find out the pH of a strong basis, it is also very easy to calculate. So this is a problem to calculate pH of the following aqueous solution. It's a lithium hydroxide, barium hydroxide, potassium hydroxide. They're all strong acid. If they're all strong acid, we can find the concentration of OH minus from the concentration of that hydroxide, lithium hydroxide. Once we find the concentration of OH minus, we can find POH, and then we will find the pH. So the hydroxide ion concentration, it's really equals to the concentration of the base. So for the A, the concentration of the hydroxide is 0.013 molar. For the barium hydroxide, so if I will go back here, barium hydroxide concentration is 0.013 molar. But if you will look at the formula, barium hydroxide makes one barium ion and it makes two hydroxide ions. So therefore, the concentration of a hydroxide ion is twice that the concentration of this barium hydroxide. So we have to multiply it by 2. And then, and this is potassium hydroxide concentration, and this is the potassium hydroxide concentration equals to the concentration of a hydroxide ion, and that's the value of that. So once we know that, then we can find the pOH. pOH is a negative logarithm of a concentration of a hydroxide ion. Once we find pOH, we can find the pH also. So, and this is also pH. They said the strong base has a pH 8.15. Calculate the original concentration of a base in a solution. This is a base, and the pH of this base is 8.15. So let's take a look at the A. So we have the pH plus pOH equals 14. So to find the concentration of OH minus, we will take 10 to the negative pOH, and then we will find the hydroxide ion concentration. So if I will look at the, this is a pH giving to us 8.15, and I can find the pOH. pOH is 5.85. And to find the concentration of the hydroxide ion, I will take 10 and raise to the power of the pOH, and then you can find it.